Hello everyone. Good morning, good afternoon, and good evening, depending upon whichever part of the world you are. I'm Ashrita from DFI office, and welcome to DFI India Groundwork 2022 special webinar. Recording of this webinar is prohibited. Online webinar recording will be available on DFI of India YouTube channel in approximately 2 weeks. You can ask your questions anytime during the presentation using the Ask Your Question box. And we welcome our session moderator, Mr. K.V. Shivanarayana, Associate Chief Consultant, L&T Infrastructure Engineering Private Limited. Mr. KVS has a total experience of 25 years as a geotechnical engineer, and he is presently heading Geotechnical Engineering Department with 20 engineers. He completed his Master's in Soil Mechanics and Foundation Engineering from Anna University. He started as a postgraduate engineer trainee in bulk material handling and water engineering. Later, he moved on to specialized works like reinforced earth retaining walls, soil nailing, and ground improvement by stone columns. We welcome you, sir. Over to you.
Thank you. Good afternoon to all. In this webinar, the totally around the 23 countries the participants are presenting in this. So the countries who are all participating has been presented here. So we welcome all of you for this webinar to know about how this National High-Speed Rail project, geotechnical engineering related works, and then the emphasis is given by the client as well as the contractor design engineers. So yeah, we can move on to the next.
Sir, you can turn your camera on.
Yeah. So in this seminar, so there is the presentation by the Dr. R.P. Singh. So he will explain more about the high-speed rail project. Then what are all the geotechnical activities, how stringently quality control related things we are following for the field investigation, laboratory testing, as well as onto the testing of the piles or the shallow foundations, etc. And also all along the alignment also he will be explaining what the difficulties the high-speed rail is facing, that one, and how they will be overcoming. So for that there is a small preamble which I will be giving as a moderator being worked in that project. So then later we will go into there is Mr. Adarsh Thakur. He is a geotechnical engineer from the high-speed rail. He is stationed at the Surat in this laboratory which you have seen in the beginning. So he will be taking you the live virtual into the laboratory. So you will find that what is the very big setup of the laboratory has been placed, and then to suit the voluminous of the work geotechnical activities. So the laboratory has been set up. It will be a wonderful one to visit and then see. Then the Q&A section will be there, question and answer section. Further, there will be closing remarks with respect to the Dr. R.P. Singh's presentation. Then next it will be presented by the details of upcoming program. Yeah, in this, I just want to tell there is I would say not one, there is a lot of good things in this project. It is very difficult to share in this small presentation being a moderator. But I would say that the National High-Speed Rail Corporation, they have done a very high number of borehole investigations all along the project stretch. So that makes them to develop a very good specification for the field work laboratory testing, as well as the testing of the piles, and also the quality control test during the piling, and the open foundations wherever it rests on the rock. So the specification to develop that specification, the high-speed rail has taken a huge effort of conducting the boreholes all along that. Now, taking forward that the contractor has mobilized all the employer requirement related equipments and then the resources required to make it as a successful. So it is like a nation's success. If the people working there is towards the project, means it is a success for the nation. Then another thing is, by looking on the voluminous of the work, the whole process of the geotechnical investigation, testing, recommendations, field load testing, everything need to be streamlined thoroughly with all the team. It is like the client, engineer, then the contractors, engineer, everybody has worked as a team and made it as a very success. Then another thing is on to the skill development took place. Is very, very enormous skill development has been taken place in this project. So in terms of the laboratory technicians, in terms of the field work, drilling operators, drilling supervisors, everybody got trained very well. So quality control wise, there is no, I would say, it is a 24/7. Everybody is working to ensure that the quality of the work has been. Then another thing is, if you are looking for any project to make it as a very success, I would say you need to have a very, very big support from the client. In this case, we had a very high support from the National High Speed Rail Corporation. And Dr. RP, he is having a very passionate about the geotechnical engineering. He always try to implement the new things. Then easy to approach him. So 24/7, he will be sometimes, if some pilot test is going on, means he will be monitoring the pilot test. Right? Some of them may be sleeping, but he will be continuously watching that one. So in addition to that, there are some institutes, IIT RAM, and also the IIT Gandhinagar, the Professor Kannan Iyer, and then Amit Prashant, they have extended a very big support to train all the technicians, orienting them towards the project. So this is how the success of the project can be done. Now, I was worked on one part of the project where it is on the C6. From there, I am telling to some information about the project. So it is like a geotechnical engineering office setting up for a project. So that office is only for a geotechnical engineers. You don't find any other person. So that is how we have started by setting up an office with the geologists, draftsmen, and then 17 engineers. Then further, this office is set very close to the investigation so that all the engineers can be able to access to the project location, that is the investigations as well as for the laboratory testing. So the investigation planning, it has been collectively handled by the high-speed rail project office as well as the client contractors planning engineers. In addition to that, the kind of the rigs required to mobilize, which requires to test the energy transfer ratio for all the drilling equipment. Now another thing is we need to train all the supervisors who are working at the drill rig locations. So this training has been taken place with a proper checklist and then mentoring them, right? So that they will get an interest, they will not lose any interest because of their workload. In addition to that, there are the 4 locations along the project corridor, there are the laboratories have been set up. So to work for this laboratory, the technicians, irrespective of their past experience, we will see that the technicians as well as the engineers to operate the consolidation and triaxial machines, they should be trained well with the IIT RAM as well as IIT Gandhinagar. So then there will be we are bringing the new equipments. So these equipments functioning of all the valves and everything need to be thoroughly checked. Then afterwards, the first report which comes, that report has to be validated. In that also, the IIT RAM Professor Kannan Iyer has been extended his full support. And he visits a fortnight to the laboratory to see any technicians are having a doubts, so that he will be clarifying that. So the training has been taken place. Then after that, there is again a thorough review. So this is how the whole process of the work has been taken place, so that we will not be doing the mistakes. Yeah. Next. So you can look about the kind of rigs which are required as per the employer requirements. This is the one of the good step the High Speed Rail Corporation has been put in the tender document, that yes, all the machines should be of the automatic, and then you need to have an automatic hammer, semi-automatic and automatic hammers. Everything will be in the hydraulic operation. Next. Yeah, you can see the rigs of the different different makes. You can see that. So every rig, once it comes to the site, it will be ETR testing will be done. Then every 25 boreholes, ETR testing will be done. Then every day the geologist will go and then monitor that all the height of fall, weight of the hammer, and then all other functions of the machines will be the same as at the time of the testing of the ETR. Further. Yeah, next. So you can see this is like a supervisory training, and then importance of the SPT testing has been explained at the site to all the drilling operators as well as the supervisors. So this kind of trainings has been regularly took place to ensure that they will be doing a proper job. Then you can see the red mark arrow is focused towards the Kannan Iyer, Professor Kannan Iyer, who will be visiting to the laboratory, and he himself 2 weeks training for the non-triaxial and then consolidation equipment test, and 4 weeks training has been given to the consolidation and triaxial equipment. So you can see the way he sits here and then observe. So every technician, he will be working on a particular testing only. He will not be moved to another one. Yeah. Yeah, I think that is the small preamble to the Dr. R.P. Singh's presentation. So now I will introduce Dr. R.P. Singh. So Dr. R.P. Singh, I met him in the last year, 2000 December. So from there, I have a very good interaction with him, sharing a lot of information. So he's a part of the team for executing this prestigious National High-Speed Rail project from Mumbai to Ahmedabad. Then he is currently looking onto all the testing, as I mentioned, that the pilot tests, then the plate load tests are there, and any other thing, wherever there is a troubleshooting is required, he will be there. Then similarly, he is associated in planning and construction of the 21-kilometer long suburban undersea tunnel of the high-speed rail at Mumbai. He has completed his master's and PhD from IIT Mumbai. He is a recipient of the Doctoral Research Award during IAC MAG 2019 conference, and he published best papers to the railway research. Then his research on track geomechanics has been complemented by the Ministry of Railways, that is Government of India, under the MD of the National High Speed Rail Corporation. Dr. RP has over 19 years of experience working in Indian Railways in various capacities, and also served as assistant professor for the tracks in the Indian Railway Institute of Civil Engineering. So it is a very good record Dr. RP is having, and his I would say he's the key person for the National High Speed Rail project for the geotechnical engineering. Yeah.
Yeah. Thank you, KVS, for a very nice briefing, and I can say a glorious briefing. So one thing means, as KVS is now moderator, so my workload for this presentation have been reduced. He have already explained many things, and whatever I left, I could not cover in the presentation. He will summarize it in the end. He is the best person because he is closely working for this project, starting from the geotechnical investigation to the foundation design and construction part. So thanks a lot, KVS, for this, for being the part of today's presentation. So good evening all, good morning or good afternoon based on your time schedule. So it is an honor and privilege for me to be present here and to present what National High Speed Rail Corporation is doing and how Ministry of Railway is planning to transform the Indian Railways. So I will be sharing some of the plannings and what new we are doing as part of the foundation construction in this project. So that I will be covering. Broadly, these are the 5 aspects which we will cover. Yeah, next. So as all of us are knowing, since independence, if we see the population growth of India have been tremendous, and in the 2031, it is the map since 1951. How was the population? How was the load on the different cities? And what will be the projection for 2020, 2031? So one thing is you can notice all from the right side graph, as we are since 1951, the air traffic and roadways have made a significant growth, and the passenger and as well as the freight traffic have shifted from railways to the other mode of the transport. So now Indian Railways is have a big plan to restore, to get back the goods, means freight as well as the passenger traffic for railways. Yeah, next. It is as all of us are knowing, the Indian Railway started its first train between Mumbai to Thane on 16th April 1853, and the current scenario we are running the freight as well as the passenger train on the same track. So for now, the planning is broadly, we will have this 1 lakh kilometer of the existing track for both passenger as well as freight. At the same time, we will be constructing new tracks for dedicatedly for passenger, semi-high speed and high speed tracks, and for freight also. The freight corridors at present, the Mumbai, Delhi and Ludhiana to Howrah freight corridors are means partly commissioned, and the remaining part will be completed in next 1 year or 2 years time. So that is one part. And second, in the entire world, whatever type of railway system you have is being adopted in Indian Railways, all type of varieties are there. In terms of gauges, broad gauge is there, meter gauge is there, both the types of narrow gauges are there, standard gauge is also there. And as I told you, now Indian Railways is transforming by setting up small companies, railway companies, and with the participation from the different stakeholders, the dedicated metros, freight corridors, high-speed corridors are coming. Yeah, next. Now coming to the Mumbai-Ahmedabad high-speed rail project, it is a most challenging and ambitious project of the Government of India, which is being implemented by National High Speed Rail Corporation. Next. So the track is being constructed between Mumbai to Sabarmati, and it will have 12 stations, as you can see from this. and the entire most of the part, about 90%, will be on the viaduct. About 25 kilometer will be on, with tunnels, and some 9 kilometer on bridges, and some part on cut and fill on embankment type, about 12.9 kilometer. The total distance, the total time taken between Mumbai to Ahmedabad will be 2 hours 7 minutes for fast trains, and for all stop trains it will be around 3 hours. The total estimated cost is 1,08,000 crore for this project, and the design speed of this project is 350 km per hour, and the operating speed will be 320 km per hour. Next. As the conventional railway system, we built on embankments, but the land requirement is more for this. So to showcase this to implement the project in the stringent timelines, High Speed Rail Corporation or government have decided to go on to choose on viaduct, so that lesser requirement of land is there, and we can easily acquire the land, and the completion period, commissioning can be done at the early stage. So instead of going to viaduct, we are either we will be constructing tunnels, or we will be going to the viaducts. So that means bridges. And the right side part, you can see there will be total land requirement will be 17.5 meter, and we will be using 12.5 meter for railway traffic, and there will be 4 meter wide service road that people can use it, and we will also use it for maintenance purposes. Next. In this one important and we can say the innovative part in surveying, we have implemented instead of doing the topographical survey using conventional method of total station, we have adopted aerial lidar survey. In this, the lidar system is kept with the helicopters, and surveying is carried out with the high resolution camera of 100 MP. We take the photographs. Next. And this ortho photos are being developed. So initial alignment is fixed on that, and land acquisition proposal have also been prepared based on this and submitted. Later on, after the submission of the proposal, we have carried out detailed surveying with the total station and DGPS surveys also. And for this innovation, NHSRCL have been awarded with Kalam Innovation in Governance Award. For geotechnical investigation, prior to bidding, about 1,200 numbers of borehole we have carried out at each kilometer, and for river bridges and stations, additional boreholes we have carried out with the conventional rigs. In the sea area also we have carried out using platoons the geotechnical investigations, and the samples have been preserved for the if any future requirement is there. Next. In Mumbai area, there is one tunnel. One tunnel for 21 kilometers. So the important part is this tunnel will be passing through below the sea, and about 7 kilometer length effectively will be below the sea. It is under the Thane Creek. So for getting the geology and other geotechnical parameters, with the help of Kawasaki Engineering Japan, we have carried out static reflection survey. For this stretch, we have carried out electrical resistivity. Next, please. So the profiling have been done, because the tunnel is going to be the most challenging part of this stretch, because Mumbai is one of the densest populated cities. So high-rise buildings are there. Tunnel will be passing below that, and tunnel will be passing through below the through undersea. So that's why it makes it complicated. Next. One more thing with Mumbai is built from 11 different islands, and the remaining part, as you see in the diagram, have been reclaimed. So there will be many challenges during the construction that we are anticipating, because the similar challenges is being faced by the other tunnel projects in Mumbai. So we will be facing that also. That will be one challenge. We have to construct well foundations on the 4 major rivers. So that will be one thing. And about 40,000 pile foundation is being constructed, and is in the stringent timelines of 2 years. That is one of the challenging tasks that this high-speed drill project is having. Next. So now coming to this, why all this emphasis is there for geotechnical investigation, ground characterization. The thing is, the foundation are always critical. It is different from all other engineering part, whether you compare it with the electrical engineering, computer science, where all the things are fixed and the construction is being carried out by the trained person in a controlled environment. Whereas in foundations, we cannot change the location, where whatever the location is coming, alignment is coming, to suit the geological condition, geotechnical data, or the profile of the soil, we have suiting to that, we have to construct our foundation. Next thing is ground is the ultimate foundation. A structure cannot rest on air. So somewhere an interface is required between the structure and the ground. That is called the foundation. So that's why it is tricky, because we need an interface that is suitable to ground and that can bear the load of the structure also. And the most challenging part is every maybe 100 meter, 200 meter, or in kilometers, if we see, location is not same. It is not like steel or concrete material. The soil have a very difficult or characterization. So what type of material it is. So that's why that investigation is little tricky. And ground behavior get affected by the seasonal variation of water table, how earthquake performance. So that's why this foundation is always critical and we have to be site specific. Next. So these are the typical steps in any foundation construction. The first part comes ground characterization, second part comes design, and third part comes whatever we have constructed, constructing the foundation, the checks of the design and the quality assurance through various tests, whether pile integrity test, load test, plate load test. There are n number of tests. So in this talk, we will be focusing on the ground characterization part. Yeah, next. As I told, it is different from all other engineering, where standard specifications are available. For ground is unique for each location, so no ready-made solution is available. We have to start from the scratch for each foundation, for each location. Next, it is just an example. You can see 3 boreholes at 100 meter distance for our project near Vapi we have taken. So means if we see the extreme boreholes, we find, okay, the rock is at very high level. But when we carried out the middle one, we found that, okay, there is a sudden deep. Rock level is not at 5 meter, but it is at 16 meter deep. So it shows how challenging the ground is. And when it comes to soil, the challenge becomes manifold. Next. As we all know, ground characterization is one of the most important part. If we don't do soil, we have to pay for soil investigation, whether we do it or not. Eventually, we pay more if we don't carry out a good ground investigation. The Leaning Tower of Pisa is the classical case for all of us, where the more than 10 times of the construction cost we have spent on the ground improvement only. So at that time, means the geotechnical engineering was not that much developed. So that they can have this excuse. But other thing is, this was the blunder that become monument, but we may not be privileged to make the blunders and by hoping just that it will become a monument. So we have to take care of it, and we have to carry out the ground characterization precisely. Next. So it is a typical geotechnical investigation plan. So we have to carry out borings. So we have to decide number of boreholes, what should be the spacing, what should be depth of borehole. So when there are codal provision, IS code also specifies it. So for our project, we have specified at the tendering stage, pre-bid stage, we have carried out at every 1 kilometer, and for construction stage, we have specified at every 100 meter. Drilling is to be carried out, and approximate depth will be about 40 meters. It may be more also. So then groundwater table monitoring is there. Field test scheme we have to finalize. Soil sampling we have to finalize. Laboratory test scheme we have to finalize. Next. For testing, the best code I can say is the Eurocode 7, which specifies what type of test is to be carried out for what properties. For laboratory testing, what type of sampling is to be taken, and for field test, what different tests based on the type of rock, coarse grained soil or fine grained soil we have to carry out. Category A type, category B and category C type of sample is you can say UDS sample category A, representative samples category B, and disturbed sample category C. It is a broad classification, and with this you can fix go vertically and horizontally, and you can decide for this type of soil what test is most efficient. Next. And based on the parameters required, so for A type of samples, you can carry out any test. For B category of soil samples, we can carry out separate specific test, and for C, only specific grain size distribution or some test we can, with some results we can get. So based on this, the testing scheme we have to finalize. Next. And for NHSR, as I told, the profile is varying from rock to black cotton soil, which is expensive soil, clay with high plasticity, silt and sand. All type of varieties are there. For this project at construction stage, we will be carrying out 5,000 boreholes, 4,000 in Gujarat region and more than 1,000 in Maharashtra region. And for field testing, we have specified we will be using automatic and semi-automatic SPT rigs. Measurement of energy transfer ratio is to be carried out. So this specification first time in the country we have enforced. And for samples, laboratory test, SPT is to be carried out at every 1 meter, and that sample is to be tested for index properties test. UDS is to be from each borehole is to be collected at every change of strata, and minimum 4 per borehole should be there. And each UDS to be tested for Triaxial, CU test and consolidation parameter, permeability, etc. Next. So in conventional rigs, SPT rigs, there are many issues. So like verticality, blows per minute, UDS extraction is also difficult. And so with this, two major challenges comes. There is no repeatability. For one machine, if you test, the parameters will be different. But for other machine, with other person you do, you will get different results. So that's why it is very less reliable. So first time in country, we have specifically mentioned automatic SPT is required for this project. Next. So we have this KVS also rightly mentioned and showed you different type of auto SPT machines. Two different categories are there. One directly imported from the manufacturer, and the second is the modified SPT rigs, which we have developed in the countries, and about 50 numbers, more than 50 numbers have been developed in Gujarat region, and that have been deployed in this project. And for each machine, at a regular frequency after 25 boreholes, we are measuring the energy ratio. Next. For now, coming to the laboratory testing, we have what usual practice is dry sieve analysis. Sample is taken and just through wooden mallet we break it, and we set off sieves, we pass it and check, okay, what percentage of weight is passing. but it is not a very accurate method if fine grained material is available. So in contract only, we have specified no dry sieve analysis. Only wet sieve analysis is to be carried out. Next. In wet sieve analysis, we soak the sample, then we pass through first 4.75 mm, then 75 micron. Whatever is retained on 4.75 mm and 75 micron, we put it in oven. Whatever passed through 75 micron, we prepare the sample for sedimentation and analysis, and we carry out hydrometer test. Next. And all three parts, whatever is retained on 4.75 mm, whatever is retained on 75 micron sieve, we put it in oven, and after 24 hours, we carry out dry sieve analysis above 75 micron. And whatever comes with the hydrometer analysis, we combine all three parts, then we get the grain size distribution curve. And the difference of dry sieve and wet sieve analysis, you can understand from this table. If we carry out dry sieve analysis for some sample, we may see that only 11% is passing through 75 micron. But for the same sample, if we carry out wet sieve analysis, we notice that about 57-58% of soil sample is passing through 75 micron. Means we might have classified our soil wrongly. So that's why, to avoid ambiguity, all soil samples is to be wet sieve analyzed in this project. Next. This is a typical, and for the sake of simplicity, we have avoided direct shear test. All the sample is to be tested for triaxial test, and with triaxial CU. In fact, it is a typical arrangement. There should be a compressor, de-airing system should be there. Only distilled water is to be used, and the Adarsh Thakur will explain in detail in the laboratory, means in the virtual tour part. So, and automatic, all the equipment should be with digital data acquisition system and with data logger also. It was contractor specification we have mentioned. This is the site laboratory at Surat. In this project, at present, 4 packages have been awarded: C4, C5, C6, and C7 major, and some bridges packages, 2 bridge packages have been allowed. So the major package is C4, which covers around 237 kilometer. Another is 88 kilometer package, that is C6, which KVS is looking after. So here this summary is for Surat lab only. About 1/3 capacity of the Surat lab have been established at Anand, at 4 different in Anand only, at 4 different labs. So that KVS is looking after. And in this, these are the number of equipment. If we combine the entire Mumbai and bullet train project, the number of triaxial and consolidation equipments which we are at site is more than, I can say, 4 times or 5 times of the total equipments available in the country. And it was considered that one of the biggest lab in Asia, the Surat lab only. And these are the number of equipments. Next. These are some photographs of our lab. Next. Why we have taken so much pain? Because as always, the client want during the design period, foundation should be safe and serviceable. Means we should be able to run the high speed at 320 km/h during the entire design period of 100 years. But bullet train is also first time for us, and ground is also challenging. So whatever best practices is available in the world, we have tried to capture it and put it in contract form, and L&T is helping us to achieve this target. And we are confident that with this project, some good practices are coming, and future projects, there will be a significant improvement. So thanks a lot.
Yeah, thank you. KVS, sir, you can take over.
Now will we going to the virtual tour? Yeah,
Yes.
I request Adarsh to take all of us to the Surat laboratory and then explain us about the facilities and then the dedication of the staff who are working there.
Good evening everyone, my name is Adarsh Thakur, presently working as a geotechnical engineer in National High Speed Rail Corporation. I welcome you all to the virtual tour of Asia's biggest geotechnical laboratory. This laboratory has been set up for the testing of C4 package, which is of total 237 kilometers from Batu to Vadodara. So around 2,450 boreholes have been drilled in all over the stretch at every 100-meter interval. And SPT test, that is the standard penetration test, has been conducted at every 1 meter depth till 40 meter, or can be increased depending upon the strata. And UDS sample has also been collected at every 3 meter interval and depending on the change of the strata starting from the 4 meter depth. So this laboratory is set up has divided in 9 modules. So first of all, there is one module which is for Triaxial Test, Triaxial Test. One module has been given independently for Consolidation Test, and another 6 modules has been given for general modules, that whatever the testing has been performed can be performed in a single module along with the Triaxial and Consolidation Test. And one module has been arranged for the sample storage and SPT samples. So SPT sample is a disturbed sample. So in disturbed sample, index properties test has been conducted, that which includes soil classification by using wet sieve analysis and hydrometer analysis. Atterberg limits has been conducted, that is the liquid limit, plastic limit and the shrinkage limit. Along with that, free soil index, specific gravity has also been conducted. In undisturbed soil sample, the tests are conducted to determine the engineering properties. So CU Triaxial Test has been conducted to determine the shear strength parameters, that is the cohesion and angle of internal friction. And Consolidation Test has been performed to determine the consolidation parameters, that is the initial void ratio, pre-consolidation pressure, coefficient of cup pressure, which are used in the settlement analysis. And we have also performed chemical analysis of water, permeability test and bulk density on these undisturbed samples. So today I am going to demonstrate you some testing, that is the wet sieve analysis testing, which is the important testing for the correct ground characterization along the depth of the borehole. And I am going to demonstrate you the CU Triaxial Test as well as the Consolidation Triaxial Test. So first of all, I am going to start with wet sieve analysis. First of all, the sample has been kept in soaking for 24 hours. So a sample of around 100 to 200 gram will be taken and it will be soaked for next 24 hours. And after soaking the samples, we will move on to wet sieve analysis. So you can see a wet sieve analysis has been performed here, and the sample which has been soaked is now washed through 75 micron sieve. The sieve is taking is the 75 micron sieve. It is very important process in wet sieve analysis, as it will divide the soil particles that we have taken into coarse and fine grained soils. The samples which will be retained above the 75 micron sieve will be the sand and the gravel sample, and the sample which will be passed through the 75 micron sieve will be the silt and clay samples. As you can see, he is doing washing the samples through 75 micron sieve, and these samples which has been passed through 75 micron sieve will be kept in a bucket. As you can see in the process, he is doing it in the bucket, and now these buckets will be kept for the sedimentation process. So as you can see here, the buckets has been kept for sedimentation for the next 24 hours. So after the sedimentation of this soil sample for next 24 hours, the water which is above the soil sample will be removed, and it will be the remaining soil will be kept in oven for next 24 hours. So as you can see here, it is the soil sample which has been kept in oven for next 24 hours. So this is the sample we have obtained, which is the sample which has been passed through 75 micron sieve, and the sample which has been retained on the 75 micron sieve will be oven dried for the next 24 hours, and the next day we will perform the dry sieve analysis by using these sieves. These are the different sieves which we will arrange as per the IS code, and we will perform the dry sieve analysis to get how much is the gravel content and how much is the sand content. Now so this is the sample. So after making this sample, we will make a solution of we will take sodium hexametaphosphate and sodium carbonate. So you can see here, these are the dispersing agents we have used so that the flocks will not be formed. So this is the sodium hexametaphosphate and this is the sodium carbonate. So around 33 gram of sodium hexaphosphate and 7 gram of sodium carbonate will be taken, and it will be thoroughly mixed in this flask. So around 1 liter of sample, 1000 ml, will be a solution will be made with this sodium hexametaphosphate and sodium carbonate, as it will be used as a dispersing agent, and this will be mixed thoroughly in this flask by shaking it. So it will be used 100 ml per soil sample. So 100 ml of solution will be used for different 10 samples. 100 ml solution will be used for one sample, and total 1 liter will be used for 10 samples. So now after mixing the solution with the soil that has been passed through 75 micron sieve, we will kept it for soaking for next 24 hours in the sodium hexametaphosphate solution. After the solution has been kept for 24 hours, it will be transferred in a mixture. So it is a mechanical stirrer that will be used to truly mix the soil. So as you can see here, after mixing the soil will be transferred to a 1000 ml flask. As you can see here, these are the flasks. The soil will then be transferred in these flasks and hydrometer testing will be started. So after transferring the soil sample through in this, it will more distilled water will be added till 1000 ml soil, and it will be shaken vigorously up and down to mix the sample thoroughly in this flask, and after that in this jar. So and after this we will put hydrometer. We will put hydrometer in this jar, and we will note down the readings of the hydrometer at different time of intervals. So at 0.5 seconds, 1 minute, 2 minutes and 4 minutes, 8 minutes, the readings will be taken, and that's how we are going to perform the hydrometer analysis as well as the wet sieve analysis. So this is a very important test which will classify the soil into coarse grain and fine grain along with the silt content and the clay content from the hydrometer analysis. So now we are moving on to CU Triaxial Test. So I am going to demonstrate how do we perform the CU Triaxial Test. As you can see, this is the triaxial apparatus. These are the triaxial cells, and these are the samples inside it. So what is the concept behind CU Triaxial Test? So the concept pursued is to make the field conditions, is to simulate the field condition as closely as possible. So whatever the process is going on the field, we are going to simulate the same field conditions here. So as you can see, that soil is under some overburden pressure. We will apply some pressure on the soil specimen, same as that we have obtained in the field by using an air compressor. So as you can see, this is the air compressor. So the pressure will be produced with in air, and it will be transferred into this soil water interface. So these are the soil water interface, where the air pressure will be converted into water pressure. As the pressure applied by the water is uniform, that's why we are converting air pressure into water pressure, and now we will apply that water pressure into the soil specimen. So now I am moving on to the triaxial cell. So as you can see here, this is the bottom pedestal. This is the base on which the sample, we will put the sample in here. So first of all, we will be having a porous stone, and as you can see, there are two holes here. So these are the holes for the measurement of pore water pressure. So one of this hole will be connected to a pore water pressure transducer. So that will measure the pore pressure inside the soil specimen. And another one is for the back pressure. We will apply the back pressure from the bottom of the soil specimen inside the soil specimen. And as you can see, there are two holes outside. So one is for drainage purpose, and second one is for the cell pressure. So we will apply the cell pressure from the knob which is outside the pedestal. So in this pedestal, first of all, we will put a porous stone which is saturated, and then we will put a filter paper. After that, you can see in the desiccator, the samples that has been extracted from the soil extractor is placed here, and we will put that soil sample onto this filter paper. And after this, we will place one more porous stone at the above of the soil specimen, and before that we will put filter paper, and then we will put this porous stone above the soil specimen for the proper drainage of the soil specimen from top and bottom. And now we will cover the soil specimen with this membrane. So this is the membrane. As you have already seen the soil sample, the soil sample was covered by a membrane. So it is a latex membrane which has been covered to the soil specimen. So as you can see, I will take one dummy sample from here. This is how we are going to get our soil sample. And above that, we will keep one more filter paper. And above that, again, we are going to have porous stone. Now using membrane stretcher, we are going to cover it by a membrane. As you can see, is taking the membrane, he will cover the membrane. After the application of this, we will place that sample, and a top pedestal will be placed over the sample after applying the rubber membrane, which will be connected through this bar for the drainage of the soil sample. Now this sample will be placed, now triaxial cell will be placed above it, and now we are moving on to the triaxial specimen. So as you can see, here is the triaxial specimen. So the soil sample is covered by a latex membrane, and top pedestal has been placed above it. Now we will place a top piston over the top pedestal that we have placed over the soil specimen. Now I am going to explain the processes involved in triaxial analysis. So the triaxial analysis is performed in 3 stages. First is saturation, second is consolidation, and the third one is shearing. So after placing the soil sample in the triaxial cell, we are going to saturate the sample. Why we are saturating the sample? Because we are maintaining the same field condition and testing the soil in the worst condition, that the sample will get saturated in the field as well. So we are testing the soil specimen in the worst condition. So for the saturation, we will apply cell pressure. So you can see the knobs here. So this knob you can see here, this is the cell pressure knob which has been connected through an outer hole, and this pressure will be applied through these valves. So as you can see, these are the confining pressure and back pressure valves. So pressure will be regulated through this pressure regulator. So we will apply some confining pressure. So as you can see, confining pressure has been applied of around 350 kPa Pascal. 350 kPa. So we are going to apply the same confining pressure that we have obtained in the field in the consolidation process. So however we are going to know that the sample is saturated. So we will calculate a Skempton's pore pressure parameter, that is B. So we will apply some pore pressure, we will apply some cell pressure, increase the cell pressure by some amount of around 40 kPa to 50 kPa, and then we will read out the pore pressure change. So as you can see here, there is a TAC, data acquisition system. So there are total 3 samples and 3 pore pressure can be seen here. So we will measure the pore pressure when we have applied the cell pressure, and after that we will get Skempton's pore pressure parameter B value, which is nothing but the ratio of change in pore water pressure to the change in confining pressure. So we will calculate B, and we will ensure that the B have reached of around value 0.95 for the saturation of the sample. Now we are going into the next stage, that is the consolidation. Now consolidation pressure will be the same pressure that the soil has been experiencing in the field. So we will apply we will increase some cell pressure and we will measure the volume change. So in consolidation process, the back pressure valve will be open, through which the water will access pore water pressure that has been developed due to that increase in confining pressure will be released out, and the volume change will be observed in the soil. So we will measure the volume change through these flasks and stopwatch. So at a different time intervals we will measure how much volume has been changed, and the continued process, the consolidation process will be continued till the volume changes becomes constant. So it may take around 4 hours, 6 hours, 8 hours, or maybe 24 hours to get the constant volume change. Now after the consolidation process, we will move on to the shearing process. So this triaxial cell will be shifted to the loading frame. So as you can see here, this is the loading frame, and this is the loading from where we will apply the loading. So we will put this triaxial cell on this pedestal, and we will, after the consolidation stage, we will calculate the strain rate that we have to apply. So strain rate will be calculated and testing will be performed in strain controlled loading. And this is the LVT from which we will measure the displacement of the soil specimen. So as you can see, 3 samples has been prepared here, and all 3 samples will be tested, and we will get stress strain curves, pore water pressure curves, and we will get 3 more circles from it, through which we will get C and phi values that we are going to determine in this test. So cohesion and angle of internal friction will be calculated from 3 different Mohr circles. And now we are moving on to the next test, that is the consolidation test. Consolidation. So this one is the consolidation ring in which sample has been placed here. So this ring will be placed in a consolidation setup. This is the base of the consolidation setup in which a porous stone has already been placed, and now we are going to take filter paper, and now we will place the soil sample above it, and again we will place the filter paper, and then again porous stone, and on which we will fix the guiding ring above it so that it will remain in same position and laterally it will not get disturbed. Above that we will give a loading plate on which we are going to fix it through a top pedestal. Now it will be fixed like this, and now it will be fixed properly by using nuts so that there will not be any disturbance on the soil sample. So you can see a ball has also been placed above it, and on that ball we will place the piston so that the load is applied vertically. This is how the consolidation setup has been arranged, and now we are moving on to consolidation test apparatus. This is the consolidation test apparatus. Here we have placed the soil sample. Inside it there is a soil sample, and it has been saturated. Like there is a flask in which water has been maintained for the saturation of the soil sample. And you can see the piston is here, so we will apply the load vertically on the soil specimen, and above it there is a LVDT which will measure the vertical displacement of the soil specimen when the load is applied over it. So it is a total 12-day process. First day we will keep it for the seating load of 5 kPa and for the saturation of the soil sample, and next 7 days we will apply the loading of different loads. So around till 800 kPa we will apply the load in different processes. So right now it is on the 7th stage, so around 320 kPa load has already been applied on it, and it is in running process. So as you can see here, the data acquisition system is here. It will collect all the data of 12 days from loading to unloading, and it will collect all the data. It will record all the data automatically from the starting of the test to the unloading of the test. From loading to unloading, all the data will be recorded automatically in this, and we will apply the load 24 hours interval. So that's how we are going to perform the consolidation test, and from this test we are going to determine the consolidation parameters, that is initial void ratio, coefficient of compression, and pre-consolidation pressure. So now I am going to show you the lab. So right now we are standing in general module 1. So this is first module in which all the testing will be performed along with the triaxial and consolidation. Now we are going to show you the lab of different modules, like we have 9 modules. Now we are moving on to consolidation modules, as you can see here. This one is the consolidation module, in which consolidation test has been performed independently, and you can see the different modules from here. Like this is the another general module. So like this we have total 9 modules, and all the testing has been performed in this laboratory, and we are performing almost 3,500 tests per day. So that's it from my side. Thank you.
Thank you, Adarsh. Thank you very much. So mostly he has covered everything by showing the laboratory facilities available. And there is a lot of emphasis is given onto the wet sieve analysis. I agree with this. It is a very good thing, because even I found in some of the projects where the sample, very small amount of the sample is collected from the SPT spoon. From there, the classification is given. But you need to have a sufficient quantity to give a classification of the material. So the conducting through the wet sieve analysis will give a real classification of the soil. Another emphasis he has shown that the triaxial equipments with the three-cell triaxial equipments, which generally we are not having in India. In this place, there is a lot of the 3-cell equipments are available in the laboratory. It is a huge. Similarly, the consolidation equipments, all the equipments are with the 3-gang, and everything is data is recorded, data logging is taking place. Some of the equipments will give the stress strain curves, and then automatically developing the C and 5 parameters. So it is a very good. Then the other tests are there where the sample extraction itself is a very good process here. Then afterwards, the one is the sample attraction. Then afterwards, conducting the other tests like a direct shear test. Then the why it has been specifically chosen the triaxial CU test, though it is a time consuming, but still it gives the both effective as well as the total stress parameters. So that is an intention of selecting this triaxial testing. Thank you very much, Adarsh, taking your time and then showing the full laboratory facilities. Now, when I look onto the Dr. RP's presentation. So he has explained about how the railway developments have been taken place in our country. The recent developments are with the large number of the dedicated freight corridor projects are going on. I was involved in those projects. Then another one is onto the national high-speed rail projects. So it is a very good step towards the development of our country. Then he has given an emphasis about the survey to be carried out. So the LiDAR survey is one of the best survey that you can get a complete information. On top of that, if you put those things into the orthophoto, so you can see even when you see this orthophoto, you can identify even the railway track also. So we have worked this in the Katni Rail project, elevated project. So we have experienced that it is a very good development. Then any success of the project, every element, one is the survey, second one is the hydrology. These two parameters are highly important. The emphasis is given in this project about doing it as a quality job through the LiDAR survey, right? That is a good step. Then it is geotechnical investigation carried out on land as well as on water. And then the boreholes are spaced at every 100-meter intervals. So in between the boreholes, what the soil strata varies has been already sufficient guidelines have given to the designers on how to interpret that. And wherever there is a rock strata, it is there. Conducting the seismic survey, seismic refraction surveys will be the better thing which has been implemented. It has been implemented even in the tunnel also. That is a good step. Then there are the testings have been specified that the open foundations, there is every open foundation will be tested for its with the plate load testing. Similarly, for the pile foundations, all the pile foundations have been tested with an instrumentation. That is, you will be recording the strains as well as the deflections along the pile with the telltale anchors. And also you will be connected with the LVDTs, and LVDTs are connected to the data loggers. So it is a complete information capturing from the testing is taking place for the further analysis. This is the one very good thing in the project. Then by looking on the volume of the project, establishing the laboratory at the site specific. Generally, we are not working in that direction, but setting up the laboratory, then afterwards the training of all the people. At the end, we feel that it is a very good step towards making the project to be successful and getting all the quality of the data. In this, you can see a lot of the digitization took place. So huge amount of the data is there. Everything has been captured through the data loggers. So that's a good step. Then there are the experts reviews are taking place. Then the procedures and the methodology of the testing adopted, right? Either it is in the plate load test or the footing load test, footing load test, or into the pile load test. The procedures have been established thoroughly. So in the beginning of the project itself, the standard has been set. Okay, these are all the formats to be used for the laboratory testing. Similarly, these are all the formats to be used for the field testing. So this kind of formats making has been simplified the work for the designers. It is the consistency of the reports are there. So this exercise, RP has put a lot of effort in the initially. I have interacted with him. It is a good step because of the number of geotechnical agencies which are involved in the project. Each fellow produces a different formats. It is very difficult for the working on the project. So this effort, I appreciate RP. Then he also mentioned about the collection of it is like the geotechnical investigation testing. It has to be correct. It should be for a site specific. It cannot be generalized across the India. So that way, work towards the particular site specific, any tests are required to be carried out. Do it and ensure the soil behavior thoroughly. Afterwards, you can implement into your projects. Now, with this, I would say I am very thankful to Dr. R.P. Singh and also the
Sir, you can
Adarsh
take few
Thakur
questions
for
which are there
giving
in the
your
question box.
good lecture, good presentation on this. Then I will move on to the questions and answers. There is one question from G. Trivedi. His question is, sir, at which step you take ETR? RP.
In KVS, you have already replied. Yeah.
Okay, but they can't see
Please
this.
continue. Please continue.
Okay, so this ETR is nothing but an energy transfer ratio. So once when you are applying the hammer blow, what is the energy it is transferring to the rods need to be measured. So for that, like a dynamic pilot tester, there will be an accelerometer and these gauges will be fixed. Then you will be applying the blows and then the data will be recorded. So for that, there is a ASTM standard is there. You can refer that ASTM standard, which states first you will be doing at a 9 meter. Afterwards, you will be conducting at the you need another 3 locations. Right? 9 meter you can do, 11 meter you can do, 13 meter you can do, like that you can keep doing it. So that is an answer for this question. Then this machine is manufactured by the PDI Institute. So PDI USA, whoever is making these pile dynamic instruments, they are manufacturing these equipments. In India, you are having one with the geodynamics, another equipment with the S&R is there, then one more equipment with the contractor. So these are only the 3 equipments. We need to have more and more equipments are required so that we will ensure every geotechnical investigation should be checked with this. Then only you will see the empirical relations that we use in the engineering is related with some energy ratio. So if you are using for a different energy ratio equipments, you cannot use those empirical relations. So that means you should ensure that the empirical relation that you are referring from some paper and then the field test you have carried out with that energy ratio, these two should be the same. Otherwise, it will be misleading to you. So that's the one question. Then the another one is Hiranya Barik. His question is, are you doing CPT, SCPT in the whole stretch of this prestigious high-speed rail project? No, we are not doing the CPT or SCPT because if this is the high-speed rail project, so the CPT and SCPT are applicable when you are having a soft materials. When you are having a hard material, the cone cannot penetrate it, and the machines are with the 20-ton capacity. So obviously, you will get a refusal. Or another locations where you are having it is a rock is there. Though you may be having some kind of the soil at the top, but we will not be using that soil, so we need to socket it into the rock. So that is the intention. That's what I am telling. Initially, the National High Speed Rail Corporation has done a lot of investigation. Based on that investigation only, the specification has been formulated. So any project, if the client does that kind of the work, it is very clear. It reduces the effort. RP, I will leave it.
Yeah, KVS, in this, just one thing I want to add. In cone penetration test, we don't get the sample. So that is one thing. So we cannot feel what type of soil is and what is its actual strength. Although the cone penetration test is having so many advantages, I am not denying it. So, but yeah, definitely for Delhi Banaras high-speed rail project, where we are in Geotech belt, we will definitely in our specification, we will keep maybe at every 1 kilometer, 1 cone penetration test, something like that. We are planning that. But in this project, we have not kept because it was first. So we want to make it robust and simple. So, and we want to see the samples instead of just
Yeah.
relying on the indirect measurement. Yeah.
Yeah. In addition to that, if the CPT test is carried out, you have to definitely do the borehole to validate the cone resistances for the different kind of materials. So that's the one question. Then the Sanjay Gupta, any studies taken up to establish effect of moisture variation, especially for expensive soils?
Yeah, Sanjay Gupta ji, this we have we are monitoring the water table variation, but this effect of this expansiveness on this foundation we have not carried out, because in the Surat region we encountered this black cotton or expansive type of soil, but at that location our foundation depth are quite large, around 40 meter, 45 meter. So we have not carried out at this moment.
Yeah. Then the Jeet Trivedi, is it possible to measure pore water pressure from top and applying back pressure at bottom? Any difficulties found in this kind of arrangement?
Adarsh, would you like to answer this?
Adarsh?
Yes.
Yeah.
Yeah, the question
Yes.
is it possible to measure pore pressure from top and applying back pressure at bottom? Any difficulties
Yes,
found
sir.
in this kind of arrangement?
Yes, sir. We can measure pore water pressure from top also. If we are attaching the pore water pressure transducer from that knob, so we can calculate pore water pressure from the top also. And about the back pressure we are already applying from the bottom part only. So back pressure has been applied from bottom, and right now we are measuring pore water pressure also from bottom. But yes, we can measure pore water pressure from top also if we are changing the knob, changing that knob and attaching pore water transducer to that knob. So it will not be that much of difficult, as we just have to change the knob and we have to attach that pore water pressure transducer in that knob.
Okay, thank you, Adarsh.
In this thing, one thing I want to add, for all the engineering colleges of Gujarat, we have made a provision on every Saturday they can visit our Surat lab and Anand lab. So for to get hands-on, or means just to visualize, just to see how the equipments are, how the field testings are there. So if anyone is interested in that, they can approach to site offices. KVS is in charge for this Anand part, and Surat Adarsh is there. So you can approach and you can go and feel it.
Yeah, last month, 18th or 20th, there are some 2 engineering colleges, students and professors have come and then visited Anand laboratory.
Yeah, till now more than 2,000 students have already visited different labs, Anand as well as Surat. So you can do that. Yeah, next.
Yeah. Sanjit Kumar, the nice presentation. Any geophysical test done for the project? Any geophysical test done for the project?
Yeah, many geophysical test in tunnel portion we have. I have mentioned in my presentation. We have carried out electrical resistivity, seismic reflection. We have carried out many geophysical, and in Vapi tunnel also we have carried out geophysical testings. But in viaduct, no. All the specific locations we have carried out where it is required. Yeah. Next.
So, that's, I think Sanjay Gupta, it is the, for Jika.
There is one question, I think, why CU triaxial test is being carried out Why not CD triaxial test? So there is two reasons. First, triaxial CU is one of the best tests, and it provides sufficient information for total stress analysis as well as effective stress analysis. Means long-term stability and short-term stability, both our objective is solved. Even the best standard or best manuals adopted in bridge foundation design like ASTO or any other, they recommend triaxial CU. But definitely a triaxial CD we can adopt, but it was just a transition phase. We earlier, as all of us are knowing, only SPT was being carried out at some location. UU test was carried out on this for the sake of just UDS testing. So we just moved one step ahead to triaxial CU, and it is solving all our technical requirements and as per standard codal provision also. So we stick to that, and but in future for few samples we can plan CD test also. Yeah.
Yeah, there is a reason. The UU test is carried out for the total stress parameter, so it is a quick test. Then CD test is carried out onto the sand kind of materials, so that the testing time will be reducing because it is the more permeable material. Then the third one will be onto the CU test. So where if you are having a material which can be done like a sand material, if it can be done with the CD test, you can do it. But the samples which will be carried out with the CU testing is because of the you need a total and effective stress parameters, so which you cannot do it on the CD testing. So that is the one the point need to be understood. Yeah, I think now the time is over. There is no more questions also. Thank you very much, RP. Thank you, Adarsh.
Yeah,
I will.
Thank you. And whatever question left, we will try to
Thank you, sir.
Respond through emails. Yeah.
Yeah, Pranav. Yeah. Thank you so much, Dr. R.P. Singh, sir, others for the wonderful presentation by both of you. And thank you so much, Sieve Analysis, sir, for wonderful moderation of the session. So you took the, you moderated the session really well. You shared further first-hand information from your side also. So we thank all three of you. Thank you so much.
Thank you.
Okay, thank you. See you all.
Thank you so much, sir.
And last detail of the upcoming webinar in this series, Groundwork 2022, webinar 4 will have on 19th April. That is again Tuesday, 5 to 6 p.m. the same time, and we'll soon announce the title and the speaker details. So thank you so much. Thank you all the
Thank you
to all the attendees.
Thank you. Bye.
Bye.
Thank you.